In topic 2, we're going to be looking at parallel and perpendicular lines. So let's start with parallel lines. Now, two parallel lines have the same slope. So if you were to find the slope of the two lines, they will be the exact same. And remember, lines are parallel if they have the same slope and they never touch. So they go forever and ever and ever, and they will never meet because they're going the exact same direction because they have the same slope. Perpendicular lines are two lines that have a right angle in between them at the one point that they do meet. So there is a right angle or a 90-degree angle between the two lines. So that means they are perpendicular, and two lines who have slopes that are negative reciprocals of one another are perpendicular. So let's quickly just look at the slopes of these two lines in this example. So starting with this line here, they gave us the rise, which is 4, and the run, which is 3. So we have 4 over 3, because that's rise over run. And then if we look at the other one, so we have 3 as the rise and negative 4 as the run. So we have 3 over negative 4. So the rise is 3 and the run is negative 4. So these two here are negative reciprocals of each other. Remember, a reciprocal is when we flip the fraction over, like so. So we just flipped the numerator and the denominator. And then a negative reciprocal just means that you put a negative sign on it. Now, that being said, if the fraction or if the slope already has a negative sign and we were to find the negative reciprocal, we would flip the numerator and the denominator, and then we would get rid of the negative sign. So then that would be the negative reciprocal. So these two are perpendicular. So let's start with example 1. Line GH passes through G. Okay, so list a bunch of points and a bunch of lines. We need to sketch the lines and determine if they are parallel or not. So I'm going to graph all 3 of these lines here, and I'll cut back to after I have them graphed. All right, so I sketched all 3 of these lines, and now let's determine if they are parallel. Now remember, 2 lines are parallel if they have the exact same slope. So we're going to find the slope for all of them. So I'm going to put slope of GH. Let's start with that one. So that's going to be equal to rise over run. And now let's look at the rise and the run. So if we start at point G, we're going to rise 1, 2, 3 in the negative direction. And then we're going to run 1, 2, 3, 4, 5, 6 in the positive direction. So our rise and run here would be negative 3 over 6. And if we were to simplify that, that would be negative 1 over 2. Next, let's look at the slope of MN. So I'm going to start at M, and let's see how many I need to rise in order to get to N. So we're going in the negative direction again. I'm going to go 1, 2, 3, 4. So our row's negative 4. And then we're going to run 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are running 9 in the positive direction. So it's going to be equal to rise over run, which is equal to negative 4 over 9. And there is no way we can simplify that. So already we see that these two slopes are not parallel. But let's see what happens when we do JK. So I'm going to start at J, and I'm going to rise to get to K, but we're actually going in the negative direction again. So 1, 2, 3, 4. Negative 4 is the rise. And then we're going in the positive direction for the run. 1, 2, 3, 4, 5, 6, 7, 8. So negative 4 over 8 is the slope for JK. And then we can definitely simplify that to negative 1 over 2. So in the end, the 3 slopes we have is negative 1 over 2, negative 4 over 9, and negative 1 over 2 again. So we're going to write a little concluding statement. We're going to say, since GH and JK have the same slope, they are parallel. MN is not parallel to GH and JK. And that's because it has a different slope. So that there is our final answer. So the blue line segment and the pink line segment are parallel, but the orange one is not. Example 2 is very similar to example 1, except this time we're not going to graph the lines in order to find the slope. We are going to use the formula that we used in topic 1. So we have two lines. They gave us 2 points on each line, and we need to determine if the lines are parallel, perpendicular, or neither. Justify your answer. So let's find the slope of both of the lines. So to start off, I'm going to label them x1, y1, x2, y2, because we're going to have to use that formula with these letters in it. So let's start off with the slope of PQ. So that is going to be equal to y2 minus y1 over x2 minus x1. So y2 minus y1, that would be 10 minus 2. And then x2 minus x1 would be negative 2 minus 7. So be careful, there's a double minus sign there, double negative. So then that's the same as 10 minus 2 over negative 2 plus 7. So then the slope of that one would be 10 minus 2, which is 8, and negative 2 plus 7 is 5. So that's the slope there. So now let's find the slope of RS. So we have slope of RS is equal to y2 minus y1 over x2 minus x1. So we have 1 minus 4 and 5 minus 3. So then we're going to have 5 over 8 for the slope of this one. So you'll notice that the slopes are reciprocals of each other. However, they're not negative reciprocals of each other. So the answer to this one is actually neither. They're neither parallel nor perpendicular. So here, let me write a concluding statement for this. So in my concluding statement, I said the slopes are not the same, so they aren't parallel. They are reciprocals, but they are not negative reciprocals, so they aren't perpendicular either. So they are neither. Now we can sketch the lines to verify the answer. So let's see what these two lines look like once we graph them. So I'm just going to cut ahead to where I have them graphed. So we're just going to plot both the points on the graph and then connect them. So here we go. I graphed these two lines. So I just continued the lines after the points that I have graphed because it says that the line passes through these coordinates. So that isn't a line segment this time. It is a full line, but it passes through those two coordinates. And as you can see, these are not parallel and they for sure aren't perpendicular either. In example 3, it says determine the slope of a line that is perpendicular to the line through E and F. So they give us 2 points there. So in order to find the slope of a line that's perpendicular, we need to figure out the slope of this line. So I'm going to use my slope formula. So I'm going to label the points x1, y1, x2, y2, and then we're going to use that formula. So slope is equal to y2 minus y1 over x2 minus x1. So then if we plug that in, we got minus 1 minus 3 over minus 4 minus 2. So that's minus 4 over minus 6, or in other words, well, we have a minus over a minus, or a negative over a negative, so that those two negatives cancel each other out. And then if we reduce this fraction, we are left with 2 over 3. So now we need the slope of a line that is perpendicular to this one. So this is the slope of this line. And in order for a line to be perpendicular to it, it needs to be the negative reciprocal. So I just put here the slope of a line perpendicular to EF is the negative reciprocal of this slope, which is 2 over 3. So then the negative reciprocal of 2 over 3 would be, well, we would take the reciprocal, which would be 3 over 2, and then we would pop in a negative sign. So negative 3 over 2 is the answer for that one. In part B, it says determine the coordinates of G so that the line EG is perpendicular to the line EF. So this one is a little tricky of a question, but I do like this question. I think it's a good one. So let's plot on our graph this EF that they gave us up here. So I'm going to put these 2 points on the graph. So here I plotted the points E and F on the graph, and you'll notice that the slope is 2 over 3, and that's the answer that we got up in part A. And we can actually confirm that by starting at F and rising 2, 1, 2, and running 3, 1, 2, 3. And look, we get to another point on the graph. And we could keep doing that slope to get to another point, or to keep extending that line. So we could rise again 2, and then run 3, 1, 2, 3, and then we end up at another point. And we could keep doing that forever and ever and ever to extend that line. But now they want us to determine the coordinates of a point G so that the line from E to G is perpendicular to the line EF. So in order for that line EG to be perpendicular, it needs to have a slope that is the negative reciprocal of 2, 3, which would be negative 3 over 2, which is the rise and the run. So then we are going to start at point E. So start at E, and we're going to do this perpendicular slope, which is negative 3 over 2. So we're going to rise negative 3, so we're going to go downwards from point E, 1, 2, 3 times, and then we're going to run 2 times, 1, 2. So we end up right here. So this line segment is perpendicular to EF, so we can label this new point as G. So I'm just going to put here the coordinates of G is 4, 0. So that is a point on our graph that is perpendicular. So now these two lines are perpendicular to each other. And we know that because the slope of the pink line segment is negative 3 over 2, and the slope of the dark blue line segment is 2 over 3. So they're negative reciprocals of each other. Now there are multiple answers that you can get for this question. There's not just one answer. You could have given me the point, we could have rose in the positive direction 1, 2, 3 times, and then we could have ran in the negative direction twice, and we would have ended up over here. So this could also be a potential other answer to that. So G could also be up there.